I'm John Rice. I'm an assistant professor in the Civil Engineering Department. Most of my research deals with risk assessment in dams. The research that I do is laboratory modeling of certain aspects dealing with erosion in dams, internal erosion caused by seepage in dams and levees.
All dams and levees, they leak water. It's called seepage. When it becomes a problem, it can erode the structure. It can undermine the foundations.
The idea is, in the last 40 years, they've tried to come up with different ways to mitigate the problems with dams and levees. One way that they've done that is put in seepage barriers. So they'll put a concrete barrier 40 feet ahead of the dam to kind of make it so that the groundwater doesn't flow and create problems that way. But in the past, they've noticed problems with cracking within this seepage barrier.
So what I tend to do is take a small part of a dam and I model it in my laboratory with controlled conditions. And what this does is it removes some of the other variables that surround that, that certain zone that I'm looking at. We have several test apparatus that we've designed here specifically to look at certain aspects of erosion. And what the graduate students are doing is they're running the test programs. They're actually building the test apparatus, running through the initial tests, kind of finding the bugs in our testing apparatus, and then redesigning so that we can get some good results.
We have it running through a flow meter, pressure differential meter, a turbidity meter, all hooked up to a data logger. I've built it from nothing with my professor. We just brainstorming from just the logistics of piping the water in here to the actual building of our device. It's been really good.
I have a number of undergraduate students also working with them, and they work as assistants to the graduate students, assembling the tests and working with the soils to get the right type of soils for our testing.
It helped me see how you can apply the concepts that you learn in class in a more hands-on environment. You can see how the equations and concepts that you learn really affect phenomena in real life.
One project that we're working on is funded by the NSF is a collaborative project with Penn State University. I work with Professor Tom Q at Penn State. What we do here is a laboratory model of the gradient hydraulic conditions that are required to cause erosion in a variety of soils. By collaborating with Dr. Q, we're able to validate his models, and then we could take his models out to real-life situations and model what will actually happen in a dam or levee. Most federal agencies and state agencies that deal with dams and levees have now incorporated risk assessment into their engineering practice. The research that I do supports that risk assessment. I don't actually do the risk assessment. What I do is I break down certain components of risk assessment and provide data or numerical correlations for whether erosion is going to occur under certain conditions or not. The risk assessors then take that data and it helps them to be more precise in their assessment of the risk of any structures. When they have a good assessment of the risk, then they can allocate their funds for either upgrading the safety of their structures or actually building new structures. And in that way, we save a lot of our federal dollars in dam and levee, both safety and construction.